So I want to show you how we can find the parametric equations for a line. The way we're going to do it is we just describe the x behavior independently from the y behavior. So for the x equation, right, we have x equals x naught plus a times t, y equals y naught plus b times t, don't worry. So x naught, y naught, this is just any point you know on the line. Okay, so right, there'll be an x coordinate and a y coordinate. Okay, a, this is just going to be the change in x. So that's just the change in the x, or x2 minus x1, however, right? B is going to be our delta y. So then m, our slope, is, right, we know that, delta y over delta x. So b over a. And now here's where the whole, you can have multiple different ways, right, to parameterize a line. So it's b over a, or, right, k times b over k times a. Any, right, any multiple, as long as you multiply the top and the bottom, right, by the same value, right? So you can change that slope, right, to go faster or slower, but you want to keep that ratio between delta y and delta x the same. Okay, so let's go ahead and practice. So we'll find multiple parametric equations between the points 2, 1, and 5, 3. And I'm just staying in quadrant 1, so I don't have to worry about negative signs right now. Okay, so let's go ahead and let's plot those. I'm going to change to green because my black pen's about dead. Okay, so even though, so 1, 2, 1, there's that point, and 1, 2, 3, 4, 5, 2, 3, right there, right? So we have this line. Oh, for goodness sakes, pretend. There we go. Right, so we could find, right, just the equation y equals mx plus b for it, but we're looking for the parametric equations. Okay, so kind of like the first step, the first one to find, right? So x equals, pick one of your points. I'll take the smaller one. So we start x naught is going to be the 2. So delta x, so 5 minus 2 times t. And y equals y naught, right? So this time I'm taking this point here to be my x naught, y naught. So y will be y naught plus, and then delta y. So that would be 3 minus 1, which is 2, right, times t. And there we go, right? So this pair of equations describes this line that I've drawn in green. So I want you to see, right, so t, x, y, I'm just going to make a quick little table. Right, so if t equals 0, using this, right, version, if t equals 0, my x value is 2 and my y value is 1. Right, so this is point right here. Here's where my t equals 0. And if t equals 1, I get 5 for my x and 3 for my y. So I get, in one step, I go from, right, 2, 1 up to 5, 3. So this is one step. Delta t equals 1. So how could I come up with a different way to describe, I still want to get this same line. And by the way, before I got too far, right, it does include all of these intermediate points. We would just have fractional t values. T does not, right, is not required to be an integer at all. Right, so I could have 0.1, 0.2, fill in all of those values along the way. Okay, so this line that I've drawn, I'll do it in green, is all going, right, in this direction of increasing t. Okay, what if I wanted to go backwards? How do you think we'd do that? And by backwards, I mean right down to the left. Right, let's just change the signs, right? We'd multiply, right, delta x and delta y by negative 1. Right, so x would be 2 minus 3t, and y would be 1 minus 2t, right? That would work. I'll do a graph here, giving myself some space. Make a quick table, t, x, y, right? So if t is 0, again, we're going to start at 2, 1. At t is 1, so increasing time. So if t is 1, my x value is going to be negative 1, and my y value will also be negative 1. So negative 1, so that gets me down here. Right? So I have the same line, but this time, right, my delta t, right, heads this way. So in order to get back to that other point, that 5, 3 that I know is on the line, right, and it's up here somewhere, that would be a delta t of -1, right? I could get there by using a t equals -1, but get me that other point that I know is there. What if I wanted to get there more slowly? Right? So if I wanted to get, we'll go back in the green direction, right, the positive direction. But what if I didn't want to get all the way up to 5, 3 in one step? What if I wanted to kind of meander my way there? Right? So now what I want to describe this step again, kind of, right? Still the same line, but we're going to go slower. Okay. Well, how about if I did 2 plus 0.3t, and y would be 1 plus 0.2t. Okay. So now it's going to take me 10 steps, right, to get from, right, that x naught, y naught that I used in my lines up to, right, that other point that I gave you. Right? So you can imagine, right, if you're programming some sort of graphics, right, and you wanted to slow something down, you just change that rate, right? You change the slope and make it smaller. But you want to keep that same relationship. You don't want to get off the line by changing either the delta x or the delta y. They both need to change by the same amount.